Hi, I'm Thomas Smart, and the second edition of my book, Serverless Beyond the Buzzword, was recently published. Now, compared to the first edition, the new book has considerably more content and delves far deeper into the different topics around serverless architecture. Now, this is a series of articles and videos where I walk through each of the new book's chapters, summarizing the content and providing some additional commentary. Chapter 4 is all about security. The cloud offers 24/7 security and operations, the cost of which is included in the service fees, with economies of scale that are difficult to replicate for a single organization. This is a great benefit, and for many smaller organizations, a higher level of security than they would be able to achieve on their own. This benefit goes even further with serverless because the provider's scope includes the security of the operating systems, software, and many other aspects. The challenge is that the cloud services are still very configurable, and this makes them flexible but easy to misconfigure. Cloud service providers operate under shared responsibility, which means the provider and the account owner are together responsible for the security of the cloud account and its applications. At a high level, the more abstracted or managed a cloud service is, the more responsibility lies with the cloud service provider. With infrastructure as a service, IaaS, or servers in the cloud, the provider is only responsible for the network, hardware, and physical access. The organization is responsible for maintaining the operating system, software, access permissions, firewall configuration, and application code. With platform as a service, PaaS, such as containers and certain database services, the provider takes care of the operating system and platform, and sometimes the software. With function as a service, FaaS or serverless, the organization is only responsible for the application code and access permissions. VPC and related configurations are optional, depending on where the microservices are being launched. Another key part of serverless security is the principle of least privilege. And this is about providing an entity with only the minimum permissions needed. It's a common security strategy, definitely not unique to serverless, but it's considerably more powerful in this architecture. Privilege means access or permissions. It sets what a given user or service can access from within an IT environment. While it is attractive and certainly easier to provide all microservices in a given solution full access to the other resources in that same application, which is basically how a server works, they should be limited to the specific resources and actions that they actually need. In a traditional monolithic solution, we achieve the principle of least privilege by assigning the least number of permissions required to an entire application. It needs that to be able to perform its task. There's no way to provide a particular set of permissions to a part of the application. As such, all levels of access and all types of actions are provided to the entire application if any part of the application needs it. Due to the distributed nature of serverless architecture, we can provide each component with its own unique set of permissions. So this means that they can be far more fine-grained and minimal compared to server permissions. For assigning permissions, AWS offers the IAM service, Identity and Access Management. It enables you to control who is authenticated and authorized to use the various cloud resources within or associated with a given application. The IAM policy defines the list of actions that an entity can take. There are AWS managed policies, such as a broad read-only policy, and we can create policies with specific permissions. IAM users are accounts intended for humans. They can have individual policies or shared policies. Users can optionally be added to one or more IAM groups where group level policies can be applied. IAM roles are assumed by trusted entities, and again, these can be users, but also applications and AWS services. Roles are assigned individual policies. So this chapter includes many security best practices. For example, sensitive data such as API keys and database credentials should not be stored in Lambda code, environment variables, or infrastructure templates where there's just a high risk of them being exposed. If credentials end up in a publicly accessible repository or storage facility, even for a few seconds, they should be considered compromised and replaced immediately. One way to monitor for such occurrences is to use tools such as Amazon Macy to scan S3 buckets for sensitive data. For Git repositories, a tool provided by AWS called Git Secrets can be used to scan for sensitive information. This chapter also covers several AWS services that can make it easier to manage security in the cloud. AWS Organizations is an account management service for consolidating multiple accounts into one organization. Single Sign-On, SSO, is a cloud-based service that simplifies central management of SSO access to multiple AWS accounts and applications. AWS Config provides a detailed view of the configuration of AWS resources in an AWS account. This is also where we can create detective and corrective controls. Amazon Guard Duty is a threat detection service that continuously monitors the cloud environment looking for malicious and unauthorized activity. Firewall Manager offers centralized management of firewall rules and other security components for the organization's accounts. A detailed overview of a third-party product called Electric Eye is also provided. This is an alternative for AWS Config that can implement highly effective detective and even corrective controls. Chapter 4 also describes a few strategies for improving security in the cloud and looks at how serverless can help comply with privacy regulations. Serverless architecture does give developers some unfair advantages for meeting privacy regulation. The architecture provides incredibly fine-grained control over the permissions of each microservice or component and the data that it can access. From a privacy perspective, serverless greatly lowers the amount of redundant access to data and provides better audit capability over the remaining access. And that brings us to the end of this chapter. A link to the book and to my blog with all of the chapter articles and videos can be found in the video description. Please connect on LinkedIn, and if you buy the book, please leave a review on Amazon. Thank you.